Today's lesson is on mass and the mole. If you remember in the previous lesson, we were talking about how to convert between moles and number of particles. Here we are going to figure out what's the relationship between how much something weighs and how many moles there are. So 12 limes and 12 eggs, even though they're relatively the same size, they don't have the same mass. And in a kind of a similar way, even though all atoms are very, very tiny, they're still not going to have the same mass. Okay, so when we look at that at a macro scale, that's going to come out in differences in weight. Right? So how does the mass of one atom relate to the mass of 1 mole of that atom? We're going to see here that something like hydrogen, okay, is a lot lighter than something like glucose. You may have seen that molecule last year. A mole is exactly 12 grams of carbon-12 atoms, right? That was the same definition from the last set of notes. The mass in grams of 1 mole of any pure substance is called its molar mass. Okay, so right now you may not fully quite understand what those words mean. That's okay. Essentially, it's saying that the amount something weighs in grams, okay, for 1 mole of it, of any pure substance, is called its molar mass. And you're going to see this a lot the rest of the year. That's going to be represented with a cursive capital M. I know there's a lot of M's in chemistry. This one's going to be a cursive capital M, okay, and that's going to represent something called molar mass. And for this, basically you're going to need your periodic table, okay? The molar mass of any element is numerically equal to its atomic mass and has the units grams per mole, okay? So if you go look at your periodic table, okay, in the upper corner of it, the molar mass of, say, carbon, okay, we're going to round it to the hundredths place, is 12.01, and the units are grams per mole, right? And we said before, this is its weight in AMUs, atomic mass units. It's also its molar mass in grams per mole, the same number, okay? All right. If you look at something like oxygen, right, its molar mass is, it says like 15.99 something, so rounding that to the hundredths place comes out 16.00 grams per mole. Okay, that's called the molar mass. Now here I'm just doing it for elements. We'll talk about how you do it for a compound here very shortly, but essentially we just add them all up for everything that's in there. Okay, this is what molar mass is. So what does that mean? That means that if I wanted exactly 1 mole of carbon atoms, okay, since not all of the carbon that we would have would be carbon-12, it's a mixture of carbon-12, 13, and 14, okay, that means I would need to go way out on the scale 12.01 grams of carbon, and every 12.01 grams of carbon is 1 mole of it, okay, and remember last time we talked about how 1 mole of a substance is 6.02 times 10 to the 23rd, right, particles, okay? So if I go way out 12.01 grams of carbon on the scale, I should have approximately, again, this is going to require, some approximation, 6.02 times 10 to the 23rd particles of carbon, atoms of carbon. Okay, so here's just a picture of weighing out 1 mole of iron. Okay, if you look at the periodic table and look at iron's weight in atomic mass units, it's 55.845. Well, it's also 55.845 grams per mole. And just so that you are familiar with this and see it, sometimes we will write this as 55.845 grams of Fe per 1 mole of Fe, of iron. Okay, so this is getting very, very detailed, okay, in your units, and that's going to be important. There's going to be a lot of different substances and numbers here coming up in the next unit or two, and being as specific as possible with what those units are, even though you may not think it's that important, is going to matter. Okay, yes, this is going to be the correct value, and grams per mole is still the right units there, but we want to start getting more specific and saying grams of iron per mole of iron. So if you wanted 1 mole of iron atoms, okay, again, that would also be if you wanted, 6.02 times 10 to the 23rd atoms of Fe. What you would do is you'd go to the scale and you'd weigh out 55.845 or as close as you could based on your scale there, okay? So what if you need, say, like 2.5 moles of something for a reaction? In this case, we're using 2.5 moles of aluminum for a reaction? Well, mathematically, okay, the number of moles times the mass in grams per mole, so this is molar mass, okay, is equal to, right, the mass in grams. So moles times molar mass equals grams. And if you're not sure why that's the case, right, if we have moles multiplied times, well, we said molar mass is really just the unit grams over moles just a moment ago. Well, look what happens to your units of moles, right? They would cancel out, and then you'd have grams, which is what we're trying to get to. So mathematically, if you need to go from moles, okay, to grams here, we're going to take the moles that we were given and multiply by, this is the molar mass of aluminum. Okay, they're finding that on the periodic table. Okay, so you have to go there for that, right? It's 26.98 something grams of aluminum for every 1 mole of aluminum. And notice what happens to your unit of moles. Moles would cancel, and then you're left with grams of aluminum, which is what this question in particular was asking. So if you're in, say, a chemistry lab, and you know that you need 2.5 moles to complete a reaction, that would mean you need to go out and weigh on the scale. Notice here 3 significant figures because there's 3 right here and 4 here, so this would only have 3. That would mean you need to go weigh on the scale 67.4 grams of aluminum. So let's try this from scratch. What is the mass of 2.15 moles of silver atoms? Well, oops, let's change that back to weight. There we go. So we have 2.15 moles of Ag, okay? So now I have moles. I need to multiply that times its molar mass. So this is where you go to your periodic table, okay? And silver is element 47. Its molecular weight is 107.87 grams of silver for every 1 mole of silver. And notice my moles of silver units there are going to cancel. When I plug this into the calculator, we'll write out the whole thing, then we'll round it off here. We end up with 231.9205, and my unit would be grams of silver. And we need to round that to 3 significant figures because this has 3 and this one's got 5, so my answer can only have 3. So the correct answer here would be 232 grams of silver. Okay, so if you needed to say that much in moles for a reaction, you'd go weigh 232 grams of silver on your scale. Okay, so it's a little bit different here. What is the mass of 4.25 moles of CH4? So now, okay, I'm no longer dealing with just an element, right? Not just an element. We have a compound. So to find the molar mass of a compound, okay, we're essentially just going to add up each of the atoms in the compound's formula. Okay, so for this one, I have 1 carbon atom, all right, times, well, I've got the molar mass off the periodic table is 12.01 grams of carbon per 1 mole. Okay. So that takes care of the carbon side of things. Then plus, I've got 4 hydrogens. So I've got 4 times, and then hydrogen on the top left is to the hundredths place, 1.01 grams per mole. Okay, so the molar mass of CH4 is 12.01 grams per mole plus 4.04. And that would give us 16.05 grams of CH4 for every 1 mole of CH4. Okay, so that's just the molar mass. So if you get a compound, right, we have to add up all of the elements and how many we have of it, okay, to get the molar mass. Well, then it's just the original problem that we were doing before, 4.25 moles of CH4 times, and then we have 16.05 grams of it for every 1 mole of it. And notice my units are going to cancel. Okay? And my answer here should have three significant figures because of the 4.25. And this comes out 68.2 grams of CH4, which would be your answer here. Okay, so the only thing different here is if we've got a compound, we just got to add up the elements and multiply them, however many we have of them, times the molar mass of an individual one. Okay, so what about a question like this? Here's a good one. How many atoms of zinc are in 47.45 grams of zinc? So now, not only do I want moles, but I've also got to turn those moles into the number of atoms. So I'm going to need Avogadro's number, right? Okay, 6.02 times 10 to the 23rd, right? Particles per 1 mole. So mathematically, what's this going to look like? Well, we're going in reverse here, 47.45 grams of zinc all the way back to atoms. So we got to turn this first into moles and then into atoms. Mathematically, okay, what that's going to look like, well, 47.45 grams of zinc. Now, this time I'm going backwards, so I'm not going to multiply times the molar mass. Okay, I'm going to divide by it. Now, go ahead and rewrite this over a little bit. But we are going to divide by the molar mass. Now, what that looks like is just multiplying times the reciprocal. But the reason we're writing it like we are is because I want you to see the units canceling. Okay, that's the goal here. All right, so that's why we are putting this written upside down. We're not writing a divide sign. We're still writing multiplying, okay, even though, let's see here, 65.409 grams of zinc. So we're putting that on the bottom. This is really 47.45 divided by 65.409 times 6.02 times 10 to the 23rd particles per 1 mole, okay? So we're going backwards here. Before we were going from moles to mass. Now we're going from mass to moles, and then we can go all the way out to number of particles, right? So the answer here would be 4.37 times 10 to the 23rd atoms of zinc. So let's try this one from scratch, okay? So keeping in mind we're starting from mass that we need to convert into moles, and then we need to convert that into number of particles, which in this case, since we're talking specifically about carbon, we're talking about atoms. So we have 94.2 grams of carbon. Okay, to get it into moles, we are going to divide by molar mass. Well, the molar mass of carbon is 12.01 grams of carbon for every 1 mole of carbon. My units, grams of carbon, cancel at that point, and I've got moles of carbon left. And then we're going to convert that into the number of atoms. So to do that, we've got to put 1 mole down here on the bottom, and we'll say carbon is for every 6.02 times 10 to the 23rd atoms of it, right? That's just using Avogadro's number. I'm putting the units in the right spot. Moles of carbon would cancel, and I'd wind up with atoms of carbon, which is exactly what we want. So 94.2 divided by 12.01 times 6.02 times 10 to the 23rd. I'm going to have 3 significant figures in the answer here. This should be 4.72 times 10 to the 24th atoms of carbon. We'll do one more of these and we'll give you kind of a wrap up. How many molecules of C2H4 are there in a 2.50 gram sample of C2H4? Okay, so the first thing we want to do before we get too far into this is get the molar mass of C2H4. Okay, we have 2 carbon atoms this time. Each carbon weighs 12.01. Okay, plus we've got 4 hydrogens, 4 times 1.01 grams per mole for hydrogen. And when we add those together, we got, what, 24.02 plus 4.04. That's going to be 28.06 grams of C2H4 for every 1 mole of C2H4. Okay, so there's our molar mass. If we're starting with mass and we want to get all the way to number of particles, again, my conversions are mass to moles to particles. It's everything included. 2.50 grams of C2H4. Okay, we're going to divide by molar mass, which is just multiplying times the reciprocal here. 28.06 grams of C2H4 for every 1 mole of C2H4. And if we're crossing off our units as we go, grams of C2H4 are going to cancel. And then to get us out of moles and into number of molecules, we'll use Avogadro's number. We need moles on the bottom, so 1 mole of C2H4 for every 6.02 times 10 to the 23rd. And this time, right, it's molecules since we're talking about a covalent substance. Putting that all together, 2.50 divided by 28.06 times 6.02 times 10 to the 23rd. And we're going to, once again, round it to 3 significant figures, 5.36 times 10 to the 22nd molecules of C2H4. Okay, so you definitely want to put this diagram into your notes, star it, box it, highlight it, whatever you got to do to make this stand out. If you're not sure what to do or how to convert between stuff, okay, this is the process. Say you're given mass. It says there's 2.50 grams of C2H4, and it wants to know how many particles is that. Well, follow the arrows here. To get to moles, I would divide by the molar mass of that substance. Okay? Then to get from moles to particles, I would multiply times Avogadro's number, and that would give me the number of particles. Or if they gave me the number of particles and wanted the mass, I would divide by Avogadro's number and multiply times the molar mass of that substance. Let's say they just give me moles and they want to know the mass. Well, all I need to do then is just multiply times the molar mass of that substance coming off the periodic table. Okay? So really, all you got to know here is that Avogadro's number is 6.02 times 10 to the 23rd particles for every 1 mole. And that for this side, you need your periodic table in order to calculate the molar mass of the substance. Okay? So this chart right here, super helpful. Okay? You just figure out where you're starting and then follow the arrows to whatever the question is asking about.